Hello everyone. Welcome to another problem session. So today I will try to do this problem that appeared in Indian Institute of Technology joint entrance exams in 2021. It appeared in 2021. And there's some wording problem here. Can be confusing, but let's just go over it. So what we have is two circular loops, and the current is going in opposite direction of each other in those loops. You might say you have how did the current come? You can imagine something like this. And there's current I1 and some other circuit making I2. So the I1 and I2 are two different circuits in a way, or two different parts of the same circuit, but they're circular. Okay. So when you have a current I1, okay, the smaller loop is an anticlockwise, and okay, with I2 greater than 2I1. So this is greater than 2I1. If you wanted to take an example, you can say I2 is a 4I1. Okay, so you might take an example, and that should help you out. Magnetic field at point xy. So xy is a arbitrary point. Could be here, could be here, could be here. Okay. Which of the following statements is or correct? So these kind of questions are pretty hard, because when you have more than one that could be right. If one is right and you got the right one, then you don't have to read the rest, right? But here you have to read every one of them. So let's read A. It says, okay, B is perpendicular to the xy plane at any point in the plane. So, so whether you're looking at this point, or we're looking at this point, or this point, or this point, the B is perpendicular to xy plane. Yeah, it's actually correct. Let's look at the what we will get. So Biot-Savart Law. Let me see. Get it. Biot-Savart Law. So it is mu naught over, in one circuit, the current is I is 4 pi. So this is for one of these. Is going to be over the circuit, and dl cross u hat dl to that point P. So this is point P, this is point P. Could be here, could be here. Say P, P1, P2, P3, could be point here. So if and then R is square that element dl to P. So if we look at any element, so let's see, we look at this element and this point. This is going to be in all the dl's of this or this. So this is going to be, so I1 is going to be B1, and if I put 2, it's going to be same kind of integral for 2 is going to be 2. So the direction was going to come from just this, right? So this dl, what is dl? dl is in the xy plane. So dl is some ai hat plus bj hat, something like that. And u hat is, it's also in the same plane. So this also ci hat plus dj hat. So when you do a cross product of this, dl cross u hat is going to be perpendicular to, so I hat with I hat will give you 0. So this will be in the k hat direction, plus or minus k hat direction, and which is perpendicular to this xy plane, you know, to the xy plane, to xy plane. So this is correct. So this, okay. So to do B, you can go and set up a maybe Biot-Savart expression, but let's look at you know, something a little bit differently. So let's look at one of these. So if I'm over here, say distance r, and if I'm over here, same distance r, p1 and p2, just from the symmetry, so the b here looks pa and pb. So b here at point A and b at point B, they should be equal to each other because they're in a completely same situation with respect to the circle, right? So I may not know BA and I may not know BB, but we can say just from symmetry, you expect that. So if I look at this situation here, some point P here, so I1 will create some B1 and I2 will create some B2. So at this point P, which is a distance R, so this is the total B, and this has to be just a function of R, can't be a function of this angle phi. So this has to be B is just a function of R. B is not a function of this direction in which P lies, angle phi. And that's what this is saying. Now, if you were to do some other way, not using symmetry arguments, it's much harder. So another way would be, maybe it's a kind of dead end, but another way you might say, okay, I'm gonna try to figure out B from 1 and B from 2. So I1 from B1, I'm gonna actually figure out what that is gonna be. So it's gonna be k hat mu naught I1 over 4 pi, and then I have to do this integral from this to that point, that's R, and this is dl. So dl will be R times minus sine theta I hat plus cosine theta j hat d theta. So that's the dl, and this R will be x minus r cosine theta I hat plus x minus y minus r sine theta j hat, and divide by the cube of this guy, right? So it's going to be like this: x minus r cosine theta square plus y minus r sine theta square 3/2. And this is integral of d theta 0 to 2 pi. Now, to show this, that this is simply a b1 is a function of r, like x comes in, when you write down b1, x and y come in the form of x square plus y square. There's no x or no y by themselves, okay? They're in this form. Now that's really hard problem, and it's close to a dead end for a test situation. So I won't go down that direction. I'll just use this symmetry argument and say this point and this point will be same as far as this is concerned. All can depend on this r, can't depend on the direction in which that point lies. Okay, so that's the B. All right. Okay, so how do we do C? Check if C is correct or not. For C, it says is non-zero at all points for r less than r. So we're looking at in this point. It says it's non-zero at all points. How about that one point? So at O, what do we expect? Well, at O, r is 0. Okay, and so B1, which is a function of r, and B2 is a function of r, so they're the function of r only. That means whatever I get here, I'll get here, so it will be some kind of a so you will have a B1 at 0 plus B2 at 0, right? Now B1, if you use the right hand rule, is coming out of the page. So at B1, so this is k hat direction, z direction. So it's coming out of page. K hat some magnitude B1 0 plus the other one is minus k hat B2 0. So this is actually k hat B1 0 minus B2 0. Okay. So what are these guys? Are they equal to each other? If they're equal to each other, then I'll contradict this, right? So how do I say for any one of them? So it's because symmetry is very easy to do that integral, So this is I1. So B1 will be I1 mu naught over 4 pi. And if that integral that I set up earlier, if you work it out, that's just going to be 2 pi R1 over R1 cube or R cube. Okay. So 4 pi 2 pi r square, yeah, 2 pi r over r square. So this whole thing turns out to be mu naught I1, and those are all R1s. R1 is R here, mu1 over 2 R1. So now to get B2, B1 at 0 and B2 at 0, this just turns out to be mu naught I2 over 2 R2. So it is saying that I2 is greater than or equal to 2 I1, right? So let's see, what if it was let's call it some factor A mu naught A I1 over 2 times 2r. So R2 is 2r, and this is just r, and this is just I1. This I1, man, I'm getting this. Let's keep it like this. This will be r, but so we've got, if you write this in terms of that, so this is going to be A over 2 B1 0. So now over here is k hat B1 0, and this is 1 minus A over 2. So I2 is depends on I2. So A is actually maybe 2A. Let's call it 2A. So I2 is 2a. So I2 is 2a, so if this a is greater than 1, then I2 is greater than 2 times I1. That's what it is saying. So so you have a k hat b10 times 1 minus a, and it says is non-zero is non-zero over here, and at some point as long as I2 and I1 are arranged properly, you can see that they will cancel. They're gonna work out as a, at some point. It's not gonna cancel at the origin, but it's going to cancel at some point. So they're opposite to each other whenever at some point, say P1, so if B1 at some point B1 at some point P1 is equal to B2 at the same point P1, and P1 is such that R is less than R, then B1 plus P2 will be 0. So there will be one point that will be 0. So this has to be incorrect. This is incorrect. Now for the D, let me erase that and come to the D. For D, we have between the two loops, at some point here. So normally outward, from this, if you think it's you mean that way in the XY plane, or you mean coming out of the XY plane in the Z direction, this direction? Which one do you mean? So if you think this, then this should be correct, right? Because between these two loops, everywhere, so we can say if interpretation is like interpretation is A versus B, if A, then D is incorrect, since B is B at that, say, point P, B at P will be plus or minus k hat. It's going to be always perpendicular to this plane. We have already established that in part A, right? So part A, we already established that. So if interpretation is B, that's coming out of the plane, which is already done in A. So if B, this was already checked in part A, so not clear why you would check it again. So maybe it's kind of this interpretation, then you will say this will be incorrect. But I'm not clear what was the interpretation was. So this will be incorrect CA. So that's a little bit disappointing that it's not as clear as which direction it is, their meaning. Maybe they should have drawn a picture and asked with that picture. Okay, so I think this is, so A is correct, B is correct, C is not correct, and D is also not correct. So that will be my answer. All right. If you haven't subscribed, can you please subscribe so we can grow this channel a little bit more? Thank you. And tell your friends about this channel. You can hit the like button or go to this website and for more information. Okay, I'll see you later. Bye.